Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 27 of NEET Physics paper 2017. Students, let us solve the question number 27. It says a car not engine, this is not hot engine, car not engine, this is car not. A car not engine having an efficiency of 1 by 10. The efficiency of Carnot engine is eta represented as 1 over 10. So it is into 100 if I multiply, then 10% efficient. 10% efficient as heat engine. So this Carnot engine having efficiency of 1 over 10 is used as heat engine. So Carnot engine having efficiency, this as heat engine is used as a refrigerator. So this is for heat engine. When it works as a heat engine, its efficiency is 10%. And this is used as, that Carnot engine is used as a refrigerator. This is a refrigerator. If the work done on the system is 10 joule, because the working of refrigerator is that you have to put some work. The work done is given by 10 joule. This is the input energy you have to supply for the refrigerator to work. This is the electrical energy you are supplying. The amount of energy absorbed from the reservoir at low temperature is. So what is that amount of heat absorbed from the reservoir? Let us see and draw the schematic diagram to understand how this refrigerator works. The refrigerator works like this. This is called sink. This is the source. This is the working substance. Here the sink temperature is T2, the source temperature is T1, always higher, hot body. This is the cold body, low temperature. The heat is taken from the sink body at low temperature, and that heat is Q2. And that cannot be possible because your aim is to take the heat from low temperature and reject it to the higher temperature. Heat cannot flow from a body at low temperature to the body at higher temperature on its own. You have to supply some energy. That is the work done. This work is done is given as 10, and this is the amount of heat that is taken from the or absorbed from the body at low temperature. That is the cabinet of the refrigerator, and that is Q2. And the amount of heat absorbed from the reservoir at low temperature, this temperature is lower, that is your aim is to find Q2. You can see that this W, Q2 and this what is rejected is Q1. This value and this value coming together is equal to Q1. So from here, if I want Q2, I must know these values. But anyway, this is how refrigerator works. And the heat engine is actually working in the reverse direction of refrigerator. Here, it takes the heat from the hot body Q1, rejects some part of the heat to the surrounding, and work is done. Here, the direction is reversed. You get output here to supply it. So efficiency of heat engine is given by 1 minus Q2 over Q1, because that is the output over input. Output over what you want and what you supply. The efficiency is output over input, and that you get this one. This is very known one. Otherwise, you can derive this. Efficiency is the work done that you want divided by what you're giving is Q1, and from that you know that This is the direction in which the energy is flowing. This is Q1, this is W, this is Q2. So I can write Q1 is W plus Q2. So from here W is Q1 minus Q2. Putting this here, Q1 minus Q2, I can separate Q1 over Q1 minus Q2 over Q1, I'll get this one. So this is the efficiency of heat engine. And as far as the refrigerator is concerned, the beta, the coefficient of performance for the refrigerator, this is the efficiency of heat engine. And the beta is again from the source you are taking the heat. So our aim is to withdraw more and more of this value so that the cabinet will be cool. So therefore Q2 is our output divided by input is the energy you're supplying W. So from here I'll get Q2 at W is same as before, that is Q1 minus Q2. So if I take the reciprocal of this value, 1 over beta equals to, this reciprocal is Q1 minus Q2 divided by Q2. Just take the reciprocal of this and reciprocal of that. If I solve this, then I'll get Q1 by Q2. I'll separate the terms and I'll get minus 1 over beta. Then I bring this to this side, then 1 plus 1 over beta equals to Q1 over Q2. So from here I will get Q2 over Q. This is a beta plus 1 by beta. So beta plus 1 divided by beta equals to Q1 over Q2. This implies Q2 over Q1. I take the reciprocal, I will get beta over 1 plus beta. This value I am getting here is substituted in this efficiency of heat engine. Then I will relate this efficiency which of the heat engine as 1 minus Q2 over Q1, and this value I will put here. If I put that, I will get 1 minus beta divided by 1 plus beta. If I take the LCM, this is 1 plus beta minus beta divided by 1 plus beta, and this is our efficiency, beta will cancel, and finally what I am getting is efficiency is equal to 1 divided by 1 plus beta. So when I get the efficiency is this one, I want actually beta, because the question you can see here, what is given is the efficiency, which is 1 over 10, and I don't know beta, so, and I know W, and I want Q2. But you can see that one value I gave you here, that beta basic meaning is this one. So Q2 is required, so I multiply W with beta, so I'll get Q2. So to get Q2, I have to find beta. So from here, 1 plus beta is 1 over eta. So beta is 1 over eta minus 1. So this is how I'll get. So I'll write that beta is 1 over eta. Eta is 1 divided by 10 minus 1. So this goes off, and this is 10 minus 1. This is 9. So beta comes out to be 9. And I just told you that beta is W. So this is Q2. Beta is Q2 over W. So from here, Q2 can be obtained by beta into W. Beta is 9, and W, the input energy that you are supplying to run the refrigerator, is 10 joule of work is done. So this is 10. So multiply, this is 90 joule of heat is to be withdrawn from the cabinet of the refrigerator. So this one, the amount of energy absorbed from the refrigerator at the low temperature, how much? This is 90 joule, and this is exactly what we got here, which is 90 joule. Okay, that is the answer to this question. Thank you.